Students, this is the Unit 8 multiple choice prep, volume and area. So this should read 8 there. It said find the volume of each figure, round your answer to the nearest tenth. Leave your answers in terms of pi for things that contain pi. So we're taking a look here at number 4. Number 4 is a prism. So it's going to be volume equals base times height. That's for a prism. The first thing you always want to do is shade your bases. And then determine what your bases are. And our bases are going to be here and then the one on the bottom. Now, every time you see base, base means area. So I like to box it and pull it apart and then define how do you find that particular area. And this here is a regular polygon. Notice the congruent hatch marks. And whenever we have a regular polygon, regular, your dad is such a regular guy, we cut pi in half. So here we're going to do perimeter. We walk it around, 1, 2, 3, 4, 5, 6. So our perimeter is going to be 6 times our edge length, which is 7. That's our perimeter, times our apothem, which is right there, 6.1 over 2. Again, I like to box that. All of this just gives you your base. Then here you do the height, and height is distance between the bases, so of course your height is going to be 12. Just clean that up. Circle, plug, chug. Number 7. Now notice number 7 comes to a point. And anything that comes to a point, we're going to do volume equals base times height over 3. So once again, your base always means area of the base, so we shade it. And so for this one, our base is a right triangle. And right triangle is going to be, the area is leg times leg over 2. And in this case, our leg is 1 is 8 times our other leg is 6 over 2. Now this gets you your base. When we talk about height in a pyramid for volume, it's always the inner height. So notice that's going to be 8 here. Now remember, there's 2 kinds of height. Sometimes you're given a slant height, which would be down the middle of the side. And if you're given that and you want the true height, of course, you use a right triangle. But in this case, you've been given the true height. So that's your base right here. Your height is there. And then it's over 3. Okay, so this one says find surface area. Surface area. A couple ways you can do this. You can unfold it or use the equation. This is a cylinder, so I'm going to establish my bases. My bases are the front and back there. And then I have basically a rectangle. So let me unfold this so it's easy to see what we have going on here. So to find my surface area, I see that I need the area of 2 bases. So there's my 2 bases. And then I basically need this area, which looks like a rectangle. We use length times width. but my width there is actually the height of the cylinder. So in this case, that'll be 6. And then here's the only tricky part. This edge here, if you look at it in the original, that edge right there, that length, if you will, is actually the circumference. So that's how we get surface area of a cylinder. Circumference times height, that's 2 bases. Now we circle, plug, plug. Here, my circumference equals d pi times my height, which is the height of the cylinder, plus 2. And of course, my bases here are circles, so that's going to be pi r squared. Our diameter, physically trace it. It's not 10. You trace it all the way down. Times your height, which is the distance between the bases, plus 2 pi, and our radius, again, you trace it as 10 squared. You get to clean that up. That's surface area for a cylinder. Okay, it says each pair is similar. So we do this. That means they're the same shape, different size. Use the information to find the scale factor of the figure from the left to the right. Now, the minute you see the word scale factor is similar, you should be thinking 1 dimension, 2 dimension, and 3 dimensions. Let's see what we actually have. We actually have the surface area. So watch very carefully. That's the actual surface area, 1500 to 15. Notice I put that in the 2 dimensions. Why? Because it's the area. If it was volume, I do volume. But I want the ratios, not the actual one. So it's important that I go ahead and I reduce. And I know what goes into both of these is 15. 15 goes into 15 one time. 15 goes in here 100 times. Now be very careful. Again, this is 2 dimensions. Technically, what I have going on here is x squared equals 100 and y squared equals 1. I want the scale factor, which is 1 dimension. I'm going to go this way. So if x squared is 100, you figure out what x is going to be. Y squared is 1, you figure out what y is going to be, and that's going to be your scale factor.